Hello students, and this is the last lectures of the topic magnetism. And in the previous lectures we are just started to discussions of the earth magnetism, or called as terrestrial magnetism. Earth magnetism. This is the last lectures of these topics of magnetism. In the previous lectures we are discussed some different magnetic equators, magnetic axis, and geographical meridians, magnetic meridians. These are two planes. Then in these lectures we are discuss the next terms or next steps, that is magnetic declinations. What is the next? This is the next third, magnetic declinations. The magnetic declination is one of the angle that is shown by the letter alpha, angle between geographic and magnetic meridian. This is the angle between geographic and that is magnetic meridians. These are two planes. Magnetic meridians is called magnetic declinations. Is called magnetic declinations. The magnetic declinations, it is very small in India's. Consider these are different two planes and they make some angle here. This is called as alpha, and these two planes are, these two different planes are, I will be shows the different colors here. This is called as magnetic meridians. This is called as magnetic meridians, that is mm, and this is called as gm, geometric meridians. Geographic meridians. And the angle between geographic and magnetic meridian is called as magnetic declinations. Then angle depth are also called as, the next is number 4, magnetic inclinations. This is the magnetic declinations. In this lectures, magnetic, next one is magnetic inclinations. Magnetic inclination, they are shows letter phi. Magnetic inclinations. The angle made by resultant magnetic fields, the angle made by resultant magnetic fields, that is, this is the considered BH, and this is the angle inclination, that is B, magnetic field inclination, that is B. I will be considered here. Then angle made by the resultant with the horizontal, this is phi at the point of inclinations. Then angle made by the resultant magnetic field with the horizontal at a plane of inclinations. The angle made by resultant magnetic field, angle made by resultant magnetic field, I will be use the letter B for a magnetic field, with horizontal at a plane, with horizontal at a plane, at a place of inclination, at a place of inclination, this is a point of inclinations. At a place of inclinations, inclination म्हणजे join or inclines or intersects. There's some different words I will be used. Earth magnetic field, the next part is I will be moving faster. The fifth, earth magnetic field. Earth magnetic field. Earth magnetic field. Then a magnetic force experienced per unit pole strength. The magnetic force experienced per unit pole strength is called magnetic field. Pole strength is called magnetic field. Magnetic field. A magnetic force per unit pole strength is called as magnetic field. It can resolve in the some components along the horizontal. It can resolved along with some components along horizontal. It's called BH. Along vertical is called BV. I can resolve here. Then the BH is equal to B cos phi. This is angle, and these two components are related with the deep angle, the angle of inclinations. Then BV is equal to B sin phi. Then the resultant magnetic field, that is BV divided by BH is equal to tan phi. Tan phi. They cancel here BB and BV. Sin phi divided by cos phi is a tan phi. Then now we are discuss some terms. This is gives the directions, the tangential directions, but what are the magnitude of the resultant magnetic field? Then we are calculate the magnitude of, that is BV square plus BH square. Then the magnitude of resultant magnetic field I will be calculate here. BV under root BV square plus BH square, not a BB, that is PV. Okay, these are all here, and we are discuss some cases, some special cases. What is the places and how much the magnetic field here? They act only vertical magnetic field or horizontal magnetic field. Let's discuss some special cases. Maybe 3 special cases here in your textbooks. The first, when the first special cases, that is at a magnetic north poles, at a magnetic north pole, a point at a magnetic north pole. That is first special case. That is case 1 at magnetic north pole, at a magnetic north pole, then B is equal to, what is the magnetic field when they are magnetic north pole? At a point is magnetic north pole, they acts only vertical components, that is BV, then BH is equal to 0, phi is exactly 90 degree, they are perpendiculars. Then this is the directions of the magnetic resultant magnetic field is upward directions, along upward directions. Then one another terms, that is second. Next cases, at a south pole, at the south pole, at south pole or south magnetic pole, then this is same, it is along only vertical, but it is in a downward direction. This vertical upward directions, that magnetic field is upward directions, in here they are downward directions, and we add the depth angle plus 180 degree. The directions is also in the different, this is vertical actions of vertical directions. When they comes to horizontal direction, this is makes 90 degree angles. They comes again for the downward directions, they makes again 90 degree, that is 180 degree. 90 degree plus 180 degree, that is 270 degree. But BH is equal to 0 and phi is equal to 270 degree. Angle is, depth angle is, resultant angle is 270 degree. And anywhere the next cases, last cases is on last content of the topics, that is anywhere of a great circle, anywhere magnetic great circle, that is magnetic great circle, and magnetic great circles, then this is acts as a BH, B is equal to BH horizontal, and BV is equal to 0 and angle is also equal to 0. This is all about the topic of magnetism. We are start discussions of the some scientist. When we are start the discussions of the topic magnetism, scientists, what are the magnets, magnetic lines of forces. In the study of these topics, we are just comparison between the electrostatic and magnetism, electric field and magnetic field, electric lines of forces and magnetic lines of forces. We are discussed the Gauss law in a both form, the magnetism as well as electrostatics. And some terms in the earth magnetism we are discussed in the 2 lectures, but we can't solve the more problems. I will be tries in the lecture topic number 13 to solve more problems and for the reminding of our formulas.